How's it going, everyone? Welcome. Euler Gonzalez here, and I want to look at the HTTP 1.0. And starting to build is this HTTP server in Node.js. So, what I'm gonna do in this next 34 minutes, which is something that I want to take time here, yes, okay, is that I'm going to read about is the paragraph 2 that comes from the history and evolution from the HTTP spec, and then look at the HTTP 1.0. So now if I browse to that and you come to me and help me to navigate to that, right? Is I think is this one. Interesting. Okay. Yep. I think this one. Oops, that's not. Oh no. What about now? Restart. There you got it. Okay. It's this one. So this is part of the this is the HTTP website. So you can take a look at that. And here, because in the previous video, what I have done is to create now an HTTP 0.9, which is something that is not here, but this is the origin of the HTTP, as a way to make sense of what this protocol initially was conceived by Tim Berners-Lee. The first is that you're gonna only fetch research, and in those research we assume that they are HTML documents or documents. And again, don't take my word for granted. Is based on the history and evolution here, right? And you are going to identify that document with a path name. So because as the web grew, the HTTP was extended to enclose request and response with message. Something that we are going to look into this video to actually make sense and answer silly questions around HTTP when some of these interviewers or technical people actually ask for that. So they have a bullet list of questions that and they want to fire at you. To see if you know is the trade-off of all of the technology that you know and that you have built. And so yeah, so that's one of them is the enclosed request and response within message. So this is now given the message structure. The transfer arbitrary data format using MIME-like media type, which is, hey, we can also want to send additional data, not only documents. And also route requests through intermediaries. This is also achieved by 1.0. This route request through intermediary, this is what make possible things like caching and proxy. So that's for example, API rate limit is like a server that sits before your server, and actually is verifying if that incoming socket or the incoming request actually reached to certain quota, right? And also it's for each one of those client requests. So I look at this and how to implement that. Just to briefly go into that is follow me along in the code here real quick. Is in the context of the Node.js environment, right? Which is at the end of the day is just using the JavaScript engine, which is at the end of the day is like an interpreted language, but right now at the stage of the art of 2026 in using ECMAScript, it behaves more like an static or like a compiler language for running a static analysis and executing the code dynamically at runtime. So based on that, the engine and since now know what it's doing is just to expose certain features via the CSS bindings that allow you to now through a C program, the Node.js bindings, to interact with the system, in this case, the research manager, which is the OS, whether it's Windows or Unix based, so like Linux or Mac. But the whole point of going deep into that is to, when you want to create now servers, there is a lot of going on here, especially in Node.js application. And I also going to create is HTTP 1.0 servers, HTTP 1.1 in PHP, Python, and Rust, right? So in this case, this is with Node.js. If you want to start creating this applications that allow you to share a message, the way you do that, at least in the OS, at least in Mac OS and Unix, Mac and Linux, is by you create now something that the OS expose to us, which is a socket. That is an internal representation that the OS have that allow you to share data from one program to another. In the context of Unix, using is the Unix standard, the file description. The TLDR is that, the thing that I think that is important to recap is that because this unit OS systems, right, or any OS, particularly the Unix, they now allow you to manage, and this is when now micro optimizations are very important at the kernel level, at the software that actually manage all of these different resources, because you actually want to harness the entire full power of that underlying hardware and make it available as an interface, pretty much like a knob in a door, or the electrical plug on a wall, right? You have now an interface that you can interact with. And here, this allows you to offers several of this interface. I'm gonna make a quick pause here because I do want to show is what is the thing that it allows or that it expose real quick. All right, so I want to make a quick recap here from one of the very interesting, and I recommend to buy this book, The Linux Programming Interface. Here I'm just showing is for educational purpose, fair use of the fundamental concepts and the system programming concepts. So in the context of the OS, right, the task that this has assigned to is that process scheduling, right? So a computer has one or more central processing units, CPUs, which execute the instruction of the program. That's one of the roles of the OS, right? The other is, so as you can see here, like other Unix systems, Linux is preemptive multitasking operating systems, which is a fancy word to say that it's going to now looking for doing multitask before it needs to do so, right? In a preemptive way. So multitasking means that multiple processes running programs can simultaneously reside in the memory and each may receive use of CPU. And preemptive means that the rules governing which process receive use of the CPU and for how long are determined by the kernel process scheduler rather than by the process themselves. So this is about the process scheduling. The kernel handles that kind of task, and it do that in this preemptive multitasking. So it means that I'm going to create all of this process, right, and simultaneously hold them into memory, and each may receive a certain part of the CPU. And preemptive means the rules governing which process receive use of the CPU and for how long they're determined by the kernel. This is what the preemptive and multitasking means. Again, a very important concept, especially as you're starting to develop your intuition about what the fundamental of the Unix system, or as the OS, has, and you can extrapolate up to certain points to any others OS. The other is memory management. So while computers' memories are enormous, at least right now, by the standard of a decade or two ago, the size of the software has also correspondingly grown, so that the physical memory, the RAM, remains a limited resource that the kernel must share among processes in an equitable and efficient fashion, like most modern operating systems. So Linux employs virtual memory management, a technique that confers two main advantages. These techniques is say, hey, the process are isolated from another and from the kernel. So that's great. So one process can read or modify the memory of another process, or one misbehaving process won't alter the state of the other programs in memory. And the other is only part of a process needs to be kept in memory, thereby lowering the memory requirement of each process and allowing more processes to be held in RAM simultaneously. So that's a very interesting thing in terms of what the kernel can do. So not only process scheduling, all right? So what are the rules that is going to govern which process receive use of the CPU and for how long? Preemptive multitasking, right? And multitasking is that the multiple process can simultaneously reside in memory. And the memory management is that because our memory is limited, and the job of the kernel or the OS is to manage this resource for us, it relies on a particular technique called the virtual memory management, which has two important properties. First, those processes are now separate or has its own particular space in memory, the memory address. So one misbehaving process won't alter the other processes. And also, the process can read or modify the memory of another process or the kernel, which is great. So this is actually guarantee you that those processes they won't compromise other processes as long as what they mentioned here. And the other is that, hey, you can only hold some piece of the process in RAM, which leads to better CPU utilization and more process along the way. And the other is provision of a file system. The kernel provides a file system on disk. So this is where you have now things like FAT32 or NFTF and TS and oh my god and TFS, right, for Mac. Right? Again, all of these are file systems. It's a way of how now a system takes a journal of all of this. Recently, there are different file system formats. Don't know what it is, but if you look at the file system here, file system, right? Let me see if I can quickly read that, but because I don't want to get lost into the details here because I don't find that's relevant. Here it is, right? So each operating system defined is how all of these different files will live in the disk, right? And how they're going to be stored. So a disk file system take advantage of the ability to this storage media to randomly address data in a short amount of time. So you have now all of this, right? FAT, exFAT, NFT, RefS. So more, I have more experience with FAT, which is a very older versions. Yep. exFAT, NTFS, which is developed by Microsoft in the 90s. EXT2, or recently the EXT4, all right, it's a journaling file system for Linux developed as a successor of the EX3. But again, that's why I am quite familiar with. And then you have other file systems as well. So in the context of, I think, yeah, they don't mention is Mac file system, but in any case, so Mac, Windows, or Linux, each one of them, not only they handle is the process scheduling, but also is the memory management, as well as the file system. So when I look at that, right, the provision of a file system, right, so the kernel provides a file system on disk, allowing files to be created, retrieved, updated, deleted, and so on. Additionally, the kernel, it says, hey, I'm going to create or terminate a process. The kernel can load a new program into memory, providing it with resource, right? Hey, where are the CPU, and you have memory, and then you need to have access to certain files, or the input and output. In the context of Unix, everything is a file, right? And that it needs in order to run, such as an instance of running programs is termed a process. Once a process has completed execution, the kernel ensures that the resources used are free for subsequent reuse by later programs. So the kernel also creates end process, reserving or allocating and deallocating resource for that program. Access to devices, so input and output, or anything that is attached to a computer, allow communication of information between the computer and the outside world, permitting input and output or both. The kernel provides programs with an interface that standardizes simply access to devices. The other is the networking, which is finally what I really care in today's video. Is the kernel transmit and receive network message packages on behalf of the user process. This task includes routing of network package to the target system. So it has now networking operations, and ultimately is the provision of a system called applications programmable interface. So process can request the kernel to perform various tasks using kernel entry point known as the system call. So this process, which are instances of your programs that are running, they might need to have access to certain things that the kernel expose, resource that the kernel expose, whether it's a network stack, or GPU, or CPU, or memory RAMs, or devices, or files, right? And I mentioned this because at the end of the day, this is what, for example, Node.js is doing all about. It's just a layer between you as a JavaScript user and that particular kernel, that because there are a lot of kernel out there You have Linux, Mac, Windows, and all the different and all the myriad of Linux distros, Red Hat, Fedora, Linux, Ubuntu, you name it, right? And so because of that, Node, the people behind Node say, no, we would like is to prefer. Started to developing is a binding that allow you from, as a JavaScript user, to interact with the underlying OS, whatever OS you are in. And this is part of the abstractions. As a software engineer, you're going to deal with a lot of these abstractions. You don't actually need to master each one of the underlying abstractions. You just only need to know what those abstractions does and how you can use them in your day-to-day operations. Now, having said that, if I go to here, right, like this, yes, you got it. Now, what I can see here is this. Real quick, in the context of the HTTP 0.9 is that, well, I do have access to now these things called the sockets. And the socket is one of the things that the OS or the API in the OS expose. Yeah, yeah. So with that is that and this things that expose is say, hey, sometimes you need this to share message across different processes, and when that happens, the kernel, because it's the one who manages all of this research and do all of these different tasks, scheduling programs, memory management, defining is this file system as well. That's right. Or provisioning of a file systems allow you to create and terminate process access to device that live outside of the, so you can have access to the outside world, right? Those devices also is the networking, right? When you need to receive network message or package from one computer to another computer. And also is you can do that is using is this API or system call that allows you to now program the kernel, right? And this programmability of the kernel is, for example, is what this net operation or this net interface exposes. So this net interface, because behind the scenes, in the case of the node, is say, hey, I'm going to give you the ability to create now is a stream-based TCP server or IPC. And in the context of TCP or IPC, is this, hey, anytime that you need to actually create a program or a server that receive or send message, right? Whether it's local, using now an IPC server, or to communicate with another process that live in another computer using the TCP protocol, now this net is what allows you to do. And this is the reason why I actually look at this lower level, quote, server. And here, when you started to use that interface, it's going to give you now this thing called a socket, which is a representation of what this message will be. And because and a good question is that when you have this representation. Now, do you want to know when something happens, especially when an image or a message happens, when the data happens. I want to do X, Y, and Z. Because Node, particularly, based on its nature, the JavaScript nature, the HTML, CSS, in JavaScript, and the DOM event model, the DOM event model described now is the event model, or how now the particularly you can respond to events. And in this case, since Node follow that particular pattern, which is anytime that you want to receive certain updates from a particular subject. A good example of this is, hey, I want to receive notification from Messi, you know. So what's Messi is doing, or I want to receive some notifications of what the HTTP protocol has been implemented recently. So HTTP or HTML, CSS or JavaScript. I want to receive feedback from those sources. So I'm going to be now an observer of that. This particular pattern is known as the the observer design pattern. So, but in any case, the point of this is since there are certain models or operations or piece of information that you want to now implement this model, right? The event emitter is that class that implement that interface, okay, or that data and functionality. So, because now with with this model, particularly with the socket, there are several of these methods that you can use by looking at this asynchronous event-driven architecture, which is a fancy way to say, hey, this is a list of well-known events, and this is and when that happens, I'm going to execute this function. You can pretty much think of this like a hash table, where the keys now is this well-defined key values, string values, right? And the values, well, is the functions that is going to be called. And in this particular case, because this is part of the method that is exposed from this event emitter, all right, which is in this case is the socket. So couple example of when you want to listen things is listen for incoming message in a TCP server, or reading or writing data in a stream. And because here the stream is also a concept that we're gonna see that later on. But the TLDR of this stream is that you can, streams are just a way of sending these chunks of data, all right? And then you somehow want is to interact with each one of them, right? Whether it's to read or write, or perhaps you want to do both operation, full duplex operation, or you want to apply certain transformations to that, which is the stream transform. So, but the TLDR is that here what I'm doing is say, hey, I'm going to create this TCP server that it is up to the Node.js binding that when I now create this server, all right, here, I'm going to now get this object injected by the node binding called as the socket that represent is this the communication or the message that can be shared. Sorry. that represent is the communication across programs, right? And since this is an event that is emitted by the OS, I don't have, because I don't trigger any of these socket things. The Node.js bindings relying is on this internal notification system that the kernel provides. And then when something happens, particularly when an event happens, they're gonna now is allow you to listen for that event and then run some computations here. And this computation is say, hey, once I started to receive data, I'm going to now give it to you as a chunk of unsigned binary unsigned 8-bit binaries as one, or I do want is to now give it to you as a string of data. This is something that you don't have control as a JavaScript user. This is something that the Node.js bindings, thanks to the kernel, is going to give it to you and make that accessible at the JavaScript runtime. So once you have access through that chunk, here you have now some additional properties that you can that allow you to transform and to make it easy for you to manage. And all of this is now this sequence of bytes in a 255 that are representing in 2 digits. Each digit is a 4-bit, and it's representing an hexadecimal because it is much more easy for us to represent that, at least visually, right? And so each one of those pair of that byte actually corresponds to a symbol. Whether the symbol you use to represent, whether it is ASCII or UTF, right? When you have that already transformed to or decoded from that table, now you're gonna have is the entire sequence of strings or characters here, right? And because now initially in the HTTP 0.9, the thing that you do here was to only send message. You say, hey, get message, for example, in the case of this, right? Sorry, my bad. This is how you actually generate those message. So I do want to get is something like this. I am escaping is this character here, like that, right? So here I'm escaping is the character of the slash, like that. And here this is the sequence of characters that the initial HTTP 0.9 server actually receive. And from there, right, so once it receives that, so now it notices the method and the path. And because there is, the only method that exists is a get, now it's going to give it to you is the proper method or the proper file or document that you ask for. And it's going to give it to you back. And for that, you have to end the connections in order to send that. Why is this? Because this is how this thing actually works initially. So that's great because at least that's serve as the first intro of what the HTTP 0.9 is doing behind the scenes. And in the client side, right? Because this library also gives you the ability to send message and to receive message, right? In order to send a message, not listen to, you have to create a connections. And again, behind the scenes, This now is relying is API, kernel API. One of them is the socket, and the socket actually create that connection. There is a particular method that create that connection for you, and it's actually mimicking that same behavior here. Hey, what will be the port you want to listen to, and what is the host domain? And once I create that connection, what do you want me to do there, right? And here I say, hey, I want you to now write this, which is actually is the characters of this HTTP protocol message. And once you receive some piece of information, right, I want you to now is transform all of those sequence of bytes into a string, putting into or concatenate on the response. And I want to actually, when the connection ends, I want to actually show you what works. So all of this is just to the HTTP 0.9. And in the context of the server here, that is finally on the okay. You got this one. No. Oh my God. Well, chill. Okay. Yeah. Here we are. Here we are. So now here. Okay. Is to actually now show is the second section of the HTTP 1.1. All right, in this from the episode of the history like so, and read about the HTTP 1.0 series. Right, it says that now it encloses those requests and response within message. The transfer arbitrarily of any data, not only exclusive documents. And also allow you to now route requests through intermediaries. So let's take a look real quick of that protocol. Please be my guest. So if I go now to here, right? Yep, on here on the document, there you got it. So if I go now here, this is the history. There you got it. Okay. If I go to here, that's right. Actually, I'm going to, remember, this is part of the HTTP semantics. There's nothing new here. It's just to browse to the history and evolution. This is the same paragraph, right? And the first section described is what the 0.9 version does, and here is describing what the 1.0 is doing. And let's actually read about this from the spec, right? From Bernie's lead. All right, it's actually loading. There you go. So RFC is just a common format on the request for comments. So this is the hypertext transfer protocol, all right? And yeah, I just want to look or to read about is the introductions and overall operations and that kind of stuff. So this is part of the table of content. Here you can look at the purpose, terminology, overall operations, notational conventions and genetic grammar, protocol parameters, HTTP version, uniform resource identifier, general syntax, URLs, datetime format, character set, content codings, media types, canonization of text. Yeah, that's go perhaps thief. But again, the protocol parameters is the HTTP version. There must be a UDI, the date and the format. What will be the character set that we're going to use in order to encode or decode this message? What will be the contents of this data that you're sending? The media types, proto tokens, and part of the HTTP message and the anatomy of this. The request, the response, the entities, right, that you can have, which is the entity headers fields, method definition that initially was only get, head, and post, right? Some of the status code definitions, and here's when you have now this, the draft of the series of codes. Informal, successful, redirections, client error, server errors, headers, fields, definitions, and allow authorization, content encoding, So all of this initial, and some of them we are quite familiar with, the headers here, right? Allow content encoding, content length, content type, last modification, location, referee, where this thing coming from, server, user agent, access authentication, security considerations, abuse of service log information, and some of this acknowledge, as you can see. So I think that let's take a look here at the purpose here. The hypertext transfer protocol is an application level protocol with the lightness and speed necessary for distributed collaborative hypermedia information system. HTTP has been in use by the World Wide Web Global Information Initiative since 1990s. This specification reflects common uses of the protocol refers to as HTTP 1.0. If I go to here, practical information systems require more functionality than simple retrieval, including search, front-end updates, and annotations. All of these things is something that makes a ton of sense in 2026, right? So you don't only want is to retrieve, but also you want is to search or update your front end or any other annotation. HTTP allows an open-ended set of methods to be used to indicate the purpose of the request. It's built on the discipline of a reference provided by the uniform resource identifier as a location and a name for indicating the resource of which a method is to be applied. So what are the resources you want to identify and the operation that you want to do, which is not only fetch, it only wants to search or update the front end. So messages are passed in a format similar to that is used by the internet mail. And the multi-purpose internet mail extension is the MIME type here. And you can take a look at that if you want to go down deep into the rabbit hole. I do think that that might go beyond of today's video, the scope of today's video. But what I do want to look is here the anatomy of the HTTP message here. So you have now, if you can read more about this, HTTP is also used as a genetic protocol for communications between user agents and proxy gateways to other internet protocols, such as MSTP. Okay, this is the reason why now you have this proxy. Why it's important to have these proxies in the network, because they are going to redirect traffic using another protocols here. Small MSTP, NTP, file transfer protocol, or Gophers, and Waze, allowing basic hypermedia access to resources available from diverse applications and simplify the implementation of user agents. Terminology. This specification uses a number of terms to refer to the roles played by participants in an object of the HTTP communication. Connection. Oh, and there you got it, right? So this specification uses a number of terms to refer to the roles played by participants in an object of an HTTP communications. So part of the anatomy here. So connection, a transport layer virtual circuit established between two application programs for the purpose of communication. This is why I mentioned sockets about, right? The message, the basic unit of HTTP communication. This terminology here, unit, is something that you're gonna hear a lot, not only here in the context of software, but in other domains. For example, in the case of the economy, you're gonna hear about that money is something that must be unit of account, unit of store value, and medium of exchange, right? The unit is something that you're gonna hear about that. But this is it. So the message is the basic unit of HTTP communication. Even in physics, at least right now, initially we thought that was the atoms, and then we look at the electrons and the protons, and then we are realizing that now there is something below this, known as the quantum realm. In any case, so that's the message, right? It's the basic unit of HTTP communication, consisting of a structured sequence of octets. Consisting of a structured sequence of octets, matching the syntax defined in the section form, and transmitted via the connections. A request, an HTTP request message, as defined in section 5. A response, an HTTP response message, as defined in section 6. A research, a network data object of service which can be identified by a UDI. The entity, a particular representation or renditions of a data source or reply from a service research that may be enclosing within a request or response. An entity consists of meta information in the form of entity headers and content in the form of entity body. Clients, an application program that establishes connections for the purpose of sending requests. Exactly. A client, is an application that establishes a connection for the purpose of sending requests. User agent, the client which initiates a request, right? These are often browsers, editors, spiders, web traversing robots, or other end user tools. But they are the one who initialize the request. And a client is an application program that establishes a connection for the purpose of sending requests. And then you have another server, right? An application that accepts connections in order to service requests by sending back response. The origin server, the server on which a given resource resides or it is to be created. Okay. Okay. Where this resource belongs to? Oh, it belongs to this computer, to this server, the origin server. And the proxy, an intermediary program which acts as both a server and a client. So it can receive message, or it can receive requests and forward requests to other places here for the purpose of making requests on behalf of other clients. Requests are serviced internally or by passing them with possible translation onto other servers. A proxy must be interpreted and, if necessary, rewrite a request message before forwarding. Proxies are often used as client-side portals through network firewalls and as a helper application for handling requests via protocol not implemented by the user agent. So again, this is an application that can act as a client and a server here, with the purpose of whatever purpose they might see fit for that task, to intercept and interpret and modify or forwarding that message. And you also have the gateway, a server which acts. A gateway is a server, so it's someone that is listening for our incoming requests. We act as an intermediary for some other server. And here is the distinction between the proxy and a gateway. Again, it's just labeled that the Tim Berners-Lee and his team have in the web we have agreed upon in order to identify the function, the behavior of this application. So proxy, it acts as a server and a client that usually, are used as a client-side portals through network firewalls, right? And the gateway is now a server, which is starting to receive incoming requests as an intermediary for other server. Unlike proxy, a gateway receives requests as if it were the origin server for the request resource. The requesting client may not be aware that it is communicating with a gateway. Exactly. The requesting client may not be aware that it is communicating with a gateway. Gateways like API rate limiting or catching, right? So API rate limiting, catching are just one of the examples here. You have now a tunnel. A tunnel is an intermediary program which is acting as a blind relay between two connections. Once active, a tunnel is not considered a party of the HTTP communication. Through the tunnel may have been initialized by an HTTP request. The tunnel ceases to exist when both ends or the relayed connections are closed. Tunnels are used when a portal is necessary and the intermediary cannot or should not interpret the relay communications. So even though the definition of a tunnel is something that you can hear a lot of, for example, of VP tunnels and stuff like that, but it's actually telling you that this tunnel has no any dog in the HTTP communication. It just now act as an intermediary program where intermediaries cannot or should not interpret the relay connection. And the other is a cache, a program's local storage or response message and the subsystems that control its message storage. Retrieval and deletion. A cache stores catchable response in order to reduce the response time and network bandwidth consumption on future. Exactly. But again, a program local storage of response message and the subsystem that controls its message storage. So they use now cache as a local. They mention cache as a local program to store response, right? And the subsystem that controls its message storage, retrieval, and deletion. And a cache stores catchable response in order to reduce the response time and network bandwidth consumption on future equivalent requests. Any client or server may include a cache, though a cache cannot be used by a server while it is acting as a tunnel. Any given program may be capable of being both a client and server, or use one of these terms refers only to the role being performed by the program for a particular connection, rather than to program's capability in general. Likewise, any server may act as an origin server proxy. Okay. Likewise, any server may act as an origin server where the resource live, the proxy, and intermediary applications that act as a server and a client to a proxy must interpret it and, if necessary, rewrite a request message. Exactly. To interpret it and rewrite the request message before forwarding, okay, a gateway, which is a server that acts as the intermediary for some other servers. And this is useful, for example, for setting an API rate limiting quota, so you don't abuse the server. So you have this gateway or a tunnel where when you need an application that doesn't rely on any intermediary along the communication. Okay. The tunnel doesn't have any dog in the fight after the HTTP communication begin. It's just that through the tunnel may be initiated by an HTTP request. And the tunnel ceases to exist when both ends on the relay connections are closed. Switching behavior based on the nature of each request. And that's very, very, very revealing in terms of understanding is all of the basic concept here. So the connection, the message, the request, the response, the resource, entity, client, user agent, server, origin server, proxy, gateway, tunnel, and cache. All of this will be now updated in the next iteration of this protocol when we look at the HTTP 1.1 later on. Got it. Holy moly. So things starting to make a lot of sense. So if right now I am here in HTTP 1.1. Let me see if I can read directly the request for comment. Oh. Nope. What about now? This document obsoletes the portion of RFC 7230. Okay. Okay. That's interesting. It's not describing too much about the HI that you get. This one. No, you want to open? Oh, really? That's interesting. Yeah, I really love how now this is organized here. The surface was updated. See this. Oh, okay. Security consideration for optimistic protocol transition in HTTP 1.1. Okay. 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 Exactly. But as the idea here is that, as you can see, each one of those protocols now are more descriptive on what they do and what they mention. Okay. All right. So in the next video, I'm going to now look at the HTTP 0.0, the terminology, and finally make sense of this thing called the HTTP 0.0, right? And well, actually make sense of the terminology that is involved here. And he's describing is how these things actually happens, and part of the overall communication and response, as you can see here. HTTP and MIME operation. And well, more about is looking at the rules and how that is going to be used and implemented, the protocol parameters, and how now these things is going to be constructed as it is. Got it. And finally, the HTTP message as it is, which can be is a simple request, simple response, or full request or full response. And of course, they have updated that into the 1.1. So if I read now, just before wrapping this video, if I now read at the HTTP 1.1, yeah, the HTTP 1.1. So if I go to that HTTP 1.1 here, yeah, here now is assuming certain things, or at least see the section 3 of HTTP for general terminology and core concept as it is. Okay, this is, you want to look at the semantics and stuff like that, the purpose and all that kind of stuff. Specification obsoleted by this conforms, length, protocol terminology, and representation, terminology and core concepts. Okay, some of the things that I was mentioned before, right, like resource, but this is for the 1.1, right? This is for the 1.1, an hypertext transfer protocol, which has been updated. Copyright notice 2022. Yeah, it's fairly recent here. And it's just an updating of the particular terminology and concept from the original 1.0. So here is talking about things like resource. What is a resource? What is representations, right? What is connection clients and server? What is a message? What is a user agent? What is the origin server? What are the intermediaries, which is a proxy and a gateway and a tunnel? And here is where describing is this more in detail, and a tunnel, right? Catches an example message exchange. So I'm gonna make a quick pause here. I'm gonna wrap this video here, and then in the next video I'm going to actually look at the HTTP 1.0 and 1.1. So take care. Bye bye.